Hi, good morning. Now we will continue with the complex numbers. Okay, in the last classes we talked about the complex numbers and some of the identities. Today we are going to start with regions in complex way. Okay. So before going to it, I will just make some of the notions in the real cases. For example, if you have a real axis like this, so this is a real axis, and you have a point x here on this axis. Okay, you can insert any point on this axis wherever depending upon the value of x. Okay, so if you have another point, let it be x0 with the condition that mod x minus x0 is less than epsilon. What does it actually mean? So it actually means all the points, okay, all the points neighbor to this x where the modulus means the magnitude, the length of this, that is less than this epsilon. So that is the meaning of it. Okay. So in the same fashion, you can also define the things in complex plane as well. So we will go to the complex plane now. So in the complex plane, you have a real axis. This is the real axis, and this is the imaginary axis. Real and imaginary. So now you have a point Z here, okay, and now I am defining in the same fashion like in the case of real. That is, I am taking mod Z minus Z0 is less than some rho. So what does it mean? How to represent? Because in a complex plane you have Z is equal to x plus I1. Depending upon the value of x and y, your Z may be here, wherever. It depends upon the value of x and y. Okay. So depending upon the x and y, your Z may be anywhere on this plane. Okay. That's why we call it as a complex plane, not a line. Because in the real case we have a real axis, only one single line, and whatever may be the points that will come on that line, okay, like a one-dimensional case. So here it is a plane, and the points on this plane, it is depending upon the x and y. That means on the real and imaginary values of this z. Okay. So now, what does this means? This means you can have the neighbors around this z. Okay. What is the importance of this neighbors? The importance of this neighbor is if you take any z0 somewhere here or here or here or here, wherever may be. Okay. Here, if you take any z0 neighbor to this z, the length of this, that is z minus z0, the modulus of z minus z0, that must be less than rho, certain value rho. So this is, we call it as the neighborhood of this point z. Okay. So only the thing is, in the case of real, you have an axis and all the points are coming on this real axis. Here you have a plane, complex plane, and by inserting this condition, you are getting a region. Okay, the region, whatever may be, any point on this circle. That is, this circle has a radius of rho. Okay, within this region, you can take any point. That is this meaning. Okay, and you can say all the points near to this z. Okay, that we call it as a neighborhood of this point is z. Okay, so this is the first thing, and the second thing, you may have the condition like this. This is greater than 0. So, what is the difference between the earlier condition and this condition? That is earlier condition was z minus z0 modulus of which is less than 0. Now, it is the situation. So, how it changes? The only thing is, here you have the region, okay, or this was your previous case, and now all the region except z is equal to z minus z0 is equal to modulus of z minus z0 equal to 0. That means the positive. So you understand? So now the region comes like this. This point is not included in the region, and all the rest of the places, that is this one. So in the first situation, here you have a disk. Okay. Now what about this one? Here you have at the z0. That means at z mod z minus z0 is equal to 0. You don't have a point, and all the other points except z minus z0 modulus of z minus z0 equal to 0, you have the points, and this is called the region now, and this we call it as a punctured disk. Okay. Actually, it is not a completed disk, it is punctured at the middle. Okay. So this is a way how to define a region in a complex plane. I hope you understand. Okay. Now we can do more and more examples related to different regions depending upon the conditions. Okay. We will check one by one. So excuse me. Okay. I will explain you one more time. So, in a complex plane, you may have some kind of many places you may have limits, because sometimes you cannot take all the values in the complex plane, because by definition z is equal to x plus I1. So, depending upon the x and y, your z may be here, anywhere on this complex plane. But in some problems, in some circumstances, you need a certain region only. Only that region you have to concentrate, and you have to look at the solution of the problems. Okay. So how to define the regions? Region you can define if you have a region where you have some neighborhood points. In z point and neighborhood points, that is defined like this. This is the z point and all the z0 values, and modulus of it, that will give you a finite value rho. Okay. So all the points within this disk you can take it in your problem, or you can consider this region, so that you will create a disk. Now you may have situations like this, where the middle point, exactly middle point, where z minus z modulus of z minus z0 equal to 0, that is not included, and all the other points less than rho, that is included. So that will give you a punctured disk. Now we will go to different regions in a complex plane, and also you have to do a few of the homeworks at your home. So I will give you another example. Real z is greater than 1. How it will be? So this is your condition now. So what is actually this condition saying to you? This is saying to you, all the regions where your real z means, what is the real z? Z is equal to x plus I1. What is the real part? Real part is your x. So all the regions where your x is greater than 1, that you are going to consider. Okay. here this is 0, this is 1, 2, 3, 4, etc. And here I, 2I, 3I, etc. Like that. Now what you have to look? You have to look the regions where your real part become greater than 1. So when you look at the z is equal to x plus iy. So this is your real part, this x is your real part. So we have to look all the regions where x is greater than 1. So what would be? This will come like this. So you can make a line that is passing through your 1. So not exactly touching on 1 because this is greater than 1. So we will take the region this. So this is the region in this complex plane for this particular condition. Okay. If in case you are told to get the region where real z is less than 1, then which area you prefer? In that situation, you have to prefer the area where your real z is less than 1. So all these regions. Okay. What you have taken now, you just exclude that and include all the other parts. Okay. So that is the situation. Now we can go for something else. Okay, I hope you are understanding this. Now let me draw something like mod z is mod z. I am taking mod z greater than 5. What would be? Mod z is greater than 5 means the magnitude of your points or the what is called that radius that should be greater than 5. Okay. So for example, here this is your 5 and this is 5I little bit. So because my drawing is not that much perfect, then you just draw a circle that is passing through your 5I minus 5I and minus 5I and all this, and you exclude these points and take the regions outside. So this will give you the region. So this is the region where mod z is greater than 5. Now just the opposite like before. If your mod z is less than 5, then what you will include? You have to include this region. Okay. So this is mod z less than 5 and outside is mod z is greater than 5. You understand how it is coming? Mod z I already told. If you have any point on this complex plane, this is a point on this complex plane z, and this will give you mod z. I already told you. Okay. So the region where the mod z is greater than 5 means all the points in this complex plane where mod z become greater than 5. And if this mod z is less than 5, this is here. Mod z is less than 5 means all the points in this complex plane where mod z become less than 5. So this is the region. And mod z greater than 5, this is the region like. Okay. Now you may take some other examples and I will give you few complex. So we will go for another example. What is the example? mod z minus z0, okay, that is less than rho. I want to plot, or I want to mark the region where mod z minus z0 is less than rho. So how you will get it? So this is easy. Yeah, this is like before what you have done. For example, this is your point, okay, and what you do, you take the radius rho, this is the radius rho, and draw the region. It may be completely in the positive side, or it may be partially in the positive in this first quadrant and then partially in the other quadrant. It depends upon where your z is coming, or where your origin located. From that point, you just draw a circle with radius rho. It may be like this. It may be you can also take, for example, this is your z, and your rho is little bit, the value is little bit higher. In that situation, this will come like this. Okay, whatever may be, you have to look only two things. One is, what is the value of rho, and all the neighborhoods surrounding to this z, where the mod z minus z0 give you less than rho. So all this. Okay, so this is a situation. Now we may go to some other example. So I am sorry, I forgot. This is the real. Okay, you know this. And this I forgot to indicate the axis. Okay, you have to understand it, because you are in a situation where you can identify much more things. I will give you another example. Okay, your mod z is less than 5 and greater than 1. How do you draw this? Again, you go for your complex plane, where you have real axis and your imaginary axis. So this is the two things. Now, mod is there. It is less than 5 and greater than 1. How do you get it? So actually here this is simply mod z is mentioned. It is not mentioned mod z minus z0. So you don't have to worry, because your z0 is 0. Okay? Your z0 is 0. So we will take a point from the origin. You go for one. This is 1, 2, 3, 4, 5. Here this is I, 2I, 3I, 4I, 5I. Here this is minus 1, minus 2, minus I, minus 2I, minus 3I, minus 4I, and minus 5I. Similarly here, minus 1, minus 2, minus 3, minus 4, minus 5. Now, what you have to look? You are excluded all the points where mod z is equal to 1. Okay? Sorry, you are excluded all the points beneath mod z is equal to 1. So that like this. So you are just making a circle with now, and all the points included above 1 and below 5. So you have to draw another circle with 5 radius. Okay? It is not actually my drawing is not that much perfect. You have to understand the concept basically. Okay? And now where is your region? Your region is this one. Okay, so this is the region. Okay, so this point is not included. This is excluded. This point is not under our consideration in our problems. And all the other regions outside 5 that also not included in our problems. Okay, so this is the way how to draw a what is called a complex region. I will give you one more example, and the remaining 2-3 problems I will give you. You have to draw it at home and you have to submit it. So we will go for another example like example is less than mod z minus z plus I less than 5. So this is a problem. What you have to do? You have to first draw the complex plane. So that is a complex plane is like this. This is your real axis, real z, and this is your imaginary z. Okay. Now what you have to look first? You have to look where is your z0, okay, and where is your z. Okay, then you have to look at it, and after that we will draw. You understand? So first we will draw a circle with radius 1 surrounding to z plus I. Okay? Oh, sorry. I just made a mistake. Not z plus I, 2 plus I. I'm sorry. That's my mistake. So you have to draw a circle with radius 1 surrounding to 2 plus I. Okay? So here this is 1, 2, 3, 4, 5, 6 on the real axis. So minus 1, minus 2, minus 3, minus 4, minus 5. Okay, and this is I, 2I, 3I, 4I, minus I, minus 2I, minus 3I, minus 4I, like that. Now you look at the point 2 plus I, this will come 2 units on the real axis and 1 unit on the imaginary axis. So this is your point. This is the point. Now you have to draw a circle with radius 1 surrounding to this point. So that will be, so this is 1 unit, so it will exist obviously here and it will go like this. So this is the point surrounding to it. Now what you have to do? You have to make another circle with the radius phi surrounding to the same point, z0 point. Okay, our z0 is 2 plus I, so you have to draw surrounding to it. So this will be, from this one 4I, 5I, again you go up, this will be 6I, because you are drawing from I, so I to 5 units, so it will come around 6I, and from here to another 5 units it will come up to 7, so this will be somewhere here. So you just make a drawing, okay, and here 1 unit, 2 unit, 3 unit, 4 unit, 5 unit, so it touches here, and this 1 unit, 2 unit, 3 unit, 4 unit, 5 unit. Okay, now I will, okay, this is not that much perfect, still you bear with me. And now, what is your complex region in this problem? The region is this one, all this region, except this and except outside this circle. Okay, so this point, all this point. So your z may be anywhere. You can choose your z point anywhere within this punctured disk, where this is excluded and this also, this region also excluded. This is the only that shaded region that is included in the problem. Okay, so this is the way how to make a complex region. So I will give you 2-3 examples. Okay, your homework is, you can draw homework. First one, I am just taking mod z is greater than 1 greater than mod z minus 3 less than 4. You draw it. And you may take the region where you have 2 less than mod z minus 1 plus 2I less than 6. Okay, so you do these things and show me through WhatsApp or some other means. Okay, this is your homework, you must do it. And I will just wind up this regions in a complex plane by this. Okay.